Well, good morning, students. So I wanted to touch base with you and make sure that you know what you're doing on this first assignment. So it says the 8 through 16 even says for each polynomial, determine the number of terms and name the coefficient of each term. Okay, so if we look at number 8, okay, it says negative 9y to the fifth power. So again, it wants us to determine the number of terms. So we have one term within this first problem. Okay, one term. This whole thing, negative 9y to the fifth power, is one term. So you would write on this piece of paper one term. Okay, then it says name the coefficient of each term. Okay, so you could do two things. You could either A, highlight the coefficient of each term, okay, or you could write underneath where you had one term or next to it the coefficient of each term, okay. So we know that a coefficient is the number that's multiplied into the variable. It's always right before the variable. It's attached to the variable. So from number 8, we know that it is negative 9. Okay. Now, if we jump ahead, so that's how you're going to do 8 and 10 and 12, 14 and 16. So if we jump ahead to 16, you're looking at it and probably saying, I don't know how to do fractions, Miss Klein. Okay. Well, again, there is a fraction, but we're not asking you to add any fractions right now. We're just asking you to determine the number of terms and name the coefficient of each term. So each term is separated by either an addition sign or a subtraction sign. Okay. So we have 1, 2, 3 terms. Okay. So there is 3 terms. All right. Now, how many coefficients do we have? Well, remember, when we have a variable without a coefficient, we know it is 1. Okay. So we have a 1. We have a negative 2. And we have a 3/4. Okay, those are our 3 coefficients. Okay. Let's erase all this. Okay, if we jump ahead, the next piece that I wanted you to do was the following. It says in each polynomial, combine like terms whenever possible. Write the result with descending power. So remember, descending powers, it means to take the highest degree. Remember, degree means power. Take the highest degree first and go down in order. So if I have, for instance, look at 25. 25 is not a very good example. I thought it had a different one. If I look at 27, I have 2 powers to the 7 and 1 power to the 9. So I would put the 9 first, and then I would add these together because they have the same variable, same exponent. Okay? And I'll explain that part in the next video.